We're approaching the end of recurrence relations, and the next part is about solving to find A and B, which are the values within your recurrence relation. And the way that we're going to do this is we're going to set up simultaneous equations and use these to solve. So, example 1, given the recurrence relation un plus 1 equals aun plus b, that is the general form of a recurrence relation. It's important to remember that the one in this part is un, and then the next term would be the un plus 1. That question featured in the multiple choice that I set the other day. Now, you've got u1 equals 40, u2 equals 50, and u3 equals 65, and you're finding the values of a and b, and then you're going to therefore find the values of u4 and u0. So we're going to take all the information that we've been given and substitute them into the recurrence relations to create two equations. So we've got u1 and u2, so let's think about how we can use these. So because this means the next term and un means the current term, you could put u2 here and u1 here, because the way that recurrence relation works is you find u2 after you found u1. You find u3 after you found u2. So I can substitute into this formula here, u2 equals au1 plus b. And then I can substitute in my actual values. So u2 is 50 and u1 is 40. So I won't write a40, I'll write 40a. Remember, always put the number before the letter. So we're replacing u1 by 40, making it 40a here. So my first equation is going to be 50 equals 40a plus b. My second equation is going to be u3 equals au2 plus b, because we know that u3 comes immediately after u2. So in a recurrence relation, that means u3 equals au2 plus b, because again, referring to the fact that this recurrence relation means the next term is equal to a times the previous term plus b. u3 is 65, u2 is 50, so a50, again, we'll write it as 50a because the letter comes after the number. And we've got our plus b. Now we can use two equations to find the value of a and b. We've got two simultaneous equations now. So let's look at it in the next slide. So 40a plus b equals 50 and 50a plus b equals 65. Now, we want to get rid of one of the letters. We're going to get rid of b in this example. We've got two positives, same signs, so we can subtract. Now, if I do 1 take away 2, I'm going to get a negative. So what I can do is I can do 2 subtract 1. So if I do 2 subtract 1, 50 take away 40 is 10a. b take away b is 0, so that disappears. 65 subtract 50 is 15. Gives me 10a equals 15. I divide by 10, and I'm getting a equals 1.5. So my value for a in the recurrence relation is going to be 1.5. I also want to find b, so I can take any of the equations above. I'm going to take this first one, 40a plus b equals 50, because the numbers are a bit smaller. I substitute in 1.5. 40 times 1.5 plus b equals 50. 40 times 1.5 is 60. 60 plus b equals 50. I subtract by 60, giving me b equals negative 10. So therefore, we have our a and b value, so we can substitute them into our original recurrence relation. So we're substituting them into this here, un plus 1 equals aun plus b. When we do that, a is 1.5 and b is negative 10, so it gives me un plus 1 equals 1.5, un subtract 10. And that is the recurrence relation, which we would usually start with. This question we've worked backwards to get what this recurrence relation formula was. So let's have a look at the next part of the question. It asks us to therefore find the values of u4 and u0. So let's do that. So first of all, we can find u0, because if we know the value of u1, we can find the value of u0, because 1 is the next term after the original term. So u1 is going to be equal to 1.5 u0 subtract 10. I know the value of u1 is 40, so I can substitute 40 in here. So it's going to be 40 equals 1.5 u0 subtract 10. I want to find what this u0 value is, so I can add on 10 from the right hand side here, and it will go to the left, becoming 40 plus 10 is 50. It will leave me with 1.5 u0 on the right hand side. I can then divide by 1.5, and that will get me u0, and it ends up being 33.33333, etc, etc. So you can just write that as 33 1/3 for the value for u0. The value for u4, well, u4 we can work out based on the value for u3, so we can substitute that into the recurrence relation. So u4 will equal 1.5 u3 subtract 10, because remember, in a recurrence relation it's always the next term is equal to 1.5 times the previous term subtract 10. So because u4 is the next term after u3, that's why we can use u4 and u3. 1.5 times 65 subtract 10. When we do that, it gives me a final answer of u4 equals 87.5. And that is our values for u0 and u4. And this is a strategy that will be used quite commonly in this topic. I am going to, in the next slide, show you a classwork example, which I'd like you to practice and hopefully get used to the process involved. So, given the recurrence relation un plus 1 equals aun plus b, u1 equals 20, u2 equals 22, u3 equals 24, find the values of a and b, hence find u4 and u0. So, what I'd like you to do just now is to pause the video, then give this example a go using your notes from the first example. Then you can go back onto the video, and I'm going to do the explanation now. So I'm going to talk through how to solve this example, and you can check your answer and see how you got on, and in any corrections you need to make, you can do that. So let's talk through this one. First of all, we're going to form our two simultaneous equations. So we've got u1, u2 and u3, so I can say that u2 equals au1 plus b, u2 is 22, u1 is 20, so I can substitute those values in. So 22 here equals, that's going to be A20, but we'll write that as 20A because it would be a bit sloppy to write the letter first. So 20A plus B. I can then do the same thing for U3 and U2. U3 equals A, U2 plus B. Remember, the reason I'm writing these ones is because a recurrence relation is always defined by the next term equals A times the previous term. So u2 and u1 correlate, u3 and u2 correlate. So u3 equals 23, a, u2 is going to be 22. Again, I don't write a22, I write 22a plus b. Give me two simultaneous equations, 20a plus b equals 22, and 22a plus b equals 23. Therefore, we can use our simultaneous equations, label them 1 and 2, the same signs again for the b, so I'm going to subtract. When I subtract them, 2a equals 1, because I'm doing 2 take away 1. If I did 1 take away 2, I would get negatives. So it's just making it a bit easier for myself. 22 take away 20 is 2a, 23 take away 22 is 1. Divide by 2, giving me 0.5 or 1/2. So you could write the fraction as well if you wanted. But we get the value of a equals 0.5. The most common mistake here is people write a equals 2, but remember it's 1 divided by 2. We then take the value of 0.5 and we sub it into either equation. We're going to go for the first one just because the numbers are slightly easier. So 20a plus b equals 22. 20 times 0.5 plus b equals 22. 20 times 0.5 is 10. Subtract 10 from the 22, b equals 12. And that gives you your a and b values. We can then take those values and we can then substitute them into the recurrence relation. So in this example, it's going to be un plus 1 equals 0.5 un plus 12, because A is 0.5 and B is 12. We can then find out the values of u0 and u4. We'll find u0 first. Now remember, u0 will relate to the u1 because u0 is the first, well, the very, very beginning term. u1 is the first term after a period of time, so they're right next to each other. So u1 we know is 20. u0 we don't know, so we'll leave it as 0.5 u0, and we've got the plus 12. We can then do a bit of algebra skills. We can take away 12, giving me 8 equals 0.5 u0, and then divide by 0.5, u0 equals 16, because 8 divided by 0.5 gives me 16. We can then find u4. u4 is going to relate to u3 because u3 is the previous term. So u4 equals 0.5 u3 plus 12. I'm going to substitute the value of u3 in, which is 23 from the question. 0.5 times 23 plus 12 gives you an answer of 23.5. So your final answers for u0 and u4 are u0 equals 16 and u4 equals 23.5. And this is going to be the process you follow every single time. Hopefully that has helped you. There is one last example for you to try. I will post the solution to that shortly, and let me know if you have any problems at all with the material in the Teams page. This will be a question that you'll see quite commonly. There will be past paper questions going up at the beginning of next week for you to try.